Thank you for joining Smart Science Educators. I am your instructor, and today we are going to look at Grade 10 Physics. The learning area is stress, strain, Young's modulus, calculation. Therefore, allow me to define some of the terms here. The stress is the force per unit cross-sectional area acting on a surface. And for the case of strain is the ratio of change of length to the original length of an object. Therefore, we can navigate to question number 1 so that you're able to solve it together. The question says a wire of cross-sectional area 2 times 10 raised to power of negative 4 square meters subjected to a tensile force of 100 Newton. Calculate the stress in the wire. Therefore, before handling this equation, you need to first write the formula that's given in brackets. So therefore, stress is given by force all over area, and the force, it is in SI unit of Newton, and then area, it is in square meters. Therefore, let's look at our question. We have the cross-sectional area and we've been given force of 100 newtons. Therefore, let's substitute into our formula. Therefore, this will be 100 Newton all over 2 times 10 raised to negative 4 square meter. Now, using a calculator, you can evaluate this. So therefore, 20 itself 1, 20 to 100, it is 50. And this gives me 50 is 500,000 Newton per square meter, or 500,000 Pascal, or 500,000 Pascal. Therefore, let's look at question number 2. A rod of length 2 meter is stretched 2 millimeters under tensile force. Calculate the strain. I've said strain is the ratio of change in length to the original length of an object. Therefore, for this case, the original length is 2 meters and the change in length, it is 2 millimeters. Therefore, if I divide with 1,000 to convert it into meters, I'll have 2 times 10 raised to power negative 3 meters. Now, therefore, let's calculate the strain. Strain is given by change in length all over original length, which is 2 times 10 raised to negative 3 meters all over 2 millimeters. Therefore, meters and meters cancels, and we remain with 1 times 10 raised to negative 3 as the answer. It has got no units, it's a ratio, or 0.123. Thank you. Now, question number 3. A spring extends by 0.05 meter when a force of 10 Newton is applied. Determine the constant of elasticity. the constant of elasticity for this case is the same as the spring constant. It is the same as the spring constant. Therefore, we use the law of elasticity where F force is equals to spring constant times extension. Now, from our question, extension is 0.05 meter and force is 10 newtons. Therefore, we can make force the subject, we can make spring constant the subject of the formula by dividing extension on both sides of the equation and remain with spring constant being equal to force all over extension. Now you counter check whether they are in the SI units. Force is in Newton and the extension it is in meters. Therefore, let's substitute. We will have 10 Newton all over 0.05 meters. For this case, we'll end up having 200 Newton per meter. Newton per meter. Now let's look at the next question. That's the SI unit for spring constant Newton per meter. Now for question number 4, a wire of initial length 1.5 meter is stretched to 1.503 meter under tensile force. Calculate the strain. Therefore, strain is given by change in length or lower original length. From our question, we have the original length as L0, which is 1.5 meter. For the case of change in length, we will find it by taking 1.503 meters minus 1.5 meter. We end up having 0.003 meters. This is the change in length. Now we are able to substitute into our formula. Therefore, strain is equals to 0.003 meters all over 1.5 meters. Therefore, meter and meter cancels and we remain with our answer as 0.002, or we can express it in standard form. Therefore, it will be 2 times 10 raised to power negative 3. For question 4b, if the stress is 3 times 10 raised to power of 6 Pascal, calculate the modulus of elasticity. Therefore, for you to be able to calculate modulus, remember is expressed as tensile stress or stress all over strain. And in our previous question, we've had our strain as 0.002 and our stress will be given in our question here. Therefore, we can insert in our formula. Therefore, this is what we'll have: 3 times 10 raised to power of 6 Pascal all over 0.002. This will result to this answer. it results to 1.5 times 10 raised to 1.5 times 10 raised to power of 9 Pascal. For question number 5, a metal rod has a cross-sectional area of 0.01 meter squared and is subjected to a tensile force of 5,000 Newton. Calculate the tensile stress. Therefore, tensile stress is given by this formula. It's given by force all over, or the tensile force all over the cross-sectional area. But force should be in Newton and this cross-sectional area should be in square meter. Therefore, let's substitute tensile stress will be 5,000 Newton all over 0.01 square meter. This results to 500,000 Newton per meter squared, or we can express in standard form, which gives us 5 times 10 raised to power of 5 Newton per meter squared. Remember, the SI unit of tensile stress, we can use Newton per meter squared, or we can use Pascal, because 1 Newton per meter squared is equals to 1 Pascal. Let's look at question number 6. Question number 6. A steel wire of 2 meter length is stretched by 4 millimeters under a tensile force of 800 Newton. The cross-sectional area of the wire is 1 times 10 raised to the power of -4 square meter. Calculate the stress in the wire. Therefore, we start with the formula. Stress is given by force all over the cross-sectional area. Remember, the definition of stress is the force acting on an object by unit cross-sectional area. Therefore, having our force as 800 Newton and our cross-sectional area as 1 times 10 raised to the power of -4 square meter, this results to this answer. It results to 8 million Newton per square meter, or 8 times 10 raised to power 6 or 6 Newton per square meter. Now you can look at question number 6b. Question number 6b, calculate the strain. Therefore, we recall the formula of strain. Recall the formula of strain. Strain is given by change in length all over original length, and for this case our change in length, it is the 4 millimeters. Therefore, we convert the 4 millimeters into meters by dividing with 1000 millimeters. This gives us 4 times 10 raised to negative 3 meters. Now our change in length, it is 4 times 10 raised to negative 3 meters, and the original length, it is 2 meters. Therefore, we substitute into our formula. We'll have sorry for that. We'll have 4 times 10 raised to negative 3 meters all over 2 meters. For this case, we'll end up having 2 times 10 raised to negative 3, or 0.002 or 0.002. Now determine the modulus of elasticity. Modulus is expressed as tensile stress all over tensile strain. For this case, we have our tensile stress as 8 million, or 8 times 10 raised to power of 6 Newton per meter squared all over tensile strain, which is 0.002. Let's confirm exactly that the tensile stress we are having. Therefore, let's get our answer here. We'll have 8 times 10 raised to power 6 divided 0.002. We end up having 4 times 10 raised to power 9 Newton per meter squared as our answer. Or you can use Pascal. For question number 7, the question says a spring stretches by 0.02 meter under a force of 5 Newton. Another spring made of different material stretches by 0.05 meter under the same force. Determine which spring is stiffer. For you to be able to determine which spring is stiffer, for this case, you have to find the spring constant for each spring. Therefore, let's name the first spring as A and the second spring as B. Therefore, let's remind of ourselves the law of elasticity, which is the Hooke's law, which gives us this formula: F is equals to Ke, force is equals to spring constant times the extension produced. Therefore, we use this formula. We make K the subject of the formula by dividing both sides of the equation with E. Therefore, spring constant K is equals to force all over extension. Now for spring A, its spring constant will be force all over E. Therefore, the same force, it is 5 Newton all over 0.02 meters. This gives us 250 Newton per meter. For spring B with spring constant KB, it will be force all over extension, which is 5 Newton, the same force all over 0.05 meters. This gives us 100 Newton per meter. Therefore, looking at the two values of these springs, you'll find out that the spring constant for A, it is greater than the spring constant for B. Therefore, this means that spring A is more stiffer. Spring A is more stiffer than spring B. For the same amount of force applied. As you can see, the spring constant for A, it is 250 Newton per meter, and for case of spring constant of B, it is 100 Newton per meter. Therefore, the spring A it is more stiffer. It requires a lot of force for it to stretch, therefore making it more stiffer. Therefore, question 7b, explain why a difference occurs. Remember, spring A has got this spring constant, which is 250 Newton per meter, and for B, it is 100 Newton per meter. Therefore, as you can see, there is a difference. Why is this difference occurring? One, these springs are made of different materials. The springs are made of different materials, therefore they have different elastic properties, hence different elastic properties. So this brings us to the end of our today's discussion, and let's meet up in our next discussion, which will be on law of elasticity. And thank you for participating. I wish you all the best in your endeavors.